Have you ever been on a road trip and then rolled down the windows and then had your arm outside the window and then you just start doing that? So the simple explanation for this is lift. Let's talk more about that. Okay, so lift is what allows airplanes to fly. There's two things that generate lift. One is the angle of attack, the angle of which the wing is pointed. Second is the shape of the wing. So the first thing, the angle of attack. So the angle of attack is important because as the airplane is flying, the wing is going this direction. And to generate lift, it begins to hit the air molecules. So I'm going to just draw the air molecules going this way. And as it hits it, the air molecules will change direction. And this pushes the wing up. This is what generates lift. Forces. But at the same time, as it hits the wing, it also creates drag. So you can't just depend on just the wing and the angle of attack to get enough lift. So now we're going to talk about the shape of the wing. The shape of the wing is very important because as the wing flies, the air goes this way. And as the wing or the airplane gains speed, the air begins to slide down like that, the ones underneath the wing, like the air molecules. But on the top, the air not only goes faster, but less air is hitting the top. So the air molecules down here are creating lift, and because the air down here is going slower, it creates bigger pressure, while up here, since the air is going faster, it creates a smaller pressure. This is greatly explained through Bernoulli's equation, P1 plus rho g H1 plus 1/2 rho V1 squared is equal to P2 plus rho g H2 plus 1/2 rho V2 squared. And to find how much lift this generates, like the wing itself, all you have to do is get P1 minus P2. So basically, change in pressure. Once you find the change in pressure, that is equal to the force of lift. So that's how Bernoulli's equation is related to the wing. But to understand Bernoulli's equation, we're going to do a few practice problems with water pipes.
Okay, so here's a good pipe problem. So we have a small pipe over here that is letting water go through, and then we have the large pipe over here. I just cut it off right here. It actually extends, and water's coming this way and pushing out this way. So we don't know the pressure over here, but we do know the pressure over here because it's open to the air. So therefore, the pressure right here is 10 to the 5th. So let's use Bernoulli's equation. So we don't know what P1 is, so that has to be there. So it's going to be plus rho g H1, but since we do not have any height in this, we can just get rid of that. And we'll also get rid of it on the other side. So plus 1/2 rho V1 squared, which that would be 5, is equal to pressure 2 plus rho g H2 plus 1/2 rho V2 squared. So we already know what rho is because the rho of water is 1,000, or the density of water. So now we can start plugging in numbers or get everything to one side. So the easiest way to solve for P1 is just to get this to the other side. So we can just get rid of that because we subtracted by it. Just above, I'm lazy. And then subtract by 1/2 rho V1 squared. And we'll put that in parentheses. So now we have 10 to the 5th plus 500, because if you include the 1/2 in that, that would be 500, times 12 squared, which would be 144, minus 500 times 25. So now I'll get out my calculator and do some calculations really fast. So 144 times 500 equals 72000 minus 500 times 25 equals 12,500 plus 1 that, and then 72000 equals that. So now we have 10 to the 5th plus 59500. That is equal to P1. And then since it's 10 to the 5th, which would be 1, 2, 3, 4, 5, and this is 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. That means it would be 159. So 1.595 times 10 to the 5th. That is what P1 is equal to. Okay. 1, 2, 3. Okay, now we're on to our second problem. This time we're going to include one more thing, height. So I already set this up so that way we don't have to worry about me writing it. So right away, since we're solving for P1 again, we have velocity here, P1 here, and we already have the density of water. And then we have the height 2, pressure 2, since it's open to the air, and then the velocity of the water at point 2 as well. So right away, we can get rid of this height. So we don't need this part whatsoever. We do need this one though. So, right, we can start solving right away. So P1 can equal, we can just subtract this one, this whole thing, and put it onto this side. So now we're going to have pressure 2 plus rho g H2 plus 1/2 rho V2 squared minus parentheses 1/2 rho V1 squared. So we have P1 is equal to 10 to the 5th plus 10,000 because there's the gravity, which is 10, times 2, so that'd be 20,000 plus 500 times 36 minus 500 times 9. So now let me get my calculator out. So, calculator, we have 500 times 36 is 18,000 minus 500 times 9, 4,500. So we can just make this into 13,500,000 or 13,500, and then plus 20,000, which would be 33,500 plus 10 to the 5th equal P1. So since we know that 10 to the 5th is just basically 10 with 4 extra zeros, so there we go, plus this 500. There we go. We can just put this in here since there's 1, 2, 3, 4, 5. Wait, yes. So now it's going to be there 1, 3, 3, 5. So 1.335 times 10 to the 5th is what pressure 1 is equal to. Okay, so now we're down to our last physics problem. So what we're trying to find is pressure 3. But what we have to do first is find the velocity in this small pipe and the pressure in this small pipe. So we're going to have to work from this side over. So let's start by finding the velocity right here, because we can't find the pressure without the velocity. So this is a newer equation that I haven't shown yet. It is A1 B1 is equal to A2 B2. The reason why they're equal to each other is because the area and the velocity, the same amount of water is moving the same amount of distance no matter what size the container is, just because water cannot be compressed. So now we're going to move on with this problem. So we have the area right here, which is 0.005, and we have the velocity. I have the velocity. One sec. It is 3 meters per second. Is V1. So we have times 3 is equal to A2, which is 0.0013 times V2. Divide by 0.0013. Divide by 0.0013. Now let's get the calculator up. So let's first multiply this part. So it's 3 times 0.005, which is 0.015, divided by 0.0013. So now V2 is equal to 11.5 meters per second. So now we have that. So we can get rid of that question mark and put 11.5 meters per second. Get rid of this because we're going to need a ton of space for this problem. I can't leave any work up. So now we're going to have to go into the pressure. So P1, or I'm just going to do 2 plus rho GH, but we don't have any height, so I'm not going to include that. 1/2 rho V2 squared is equal to P1 plus 1 half rho B1 squared. So we don't have this one, so we're just going to move this to this side. So we have P2 is equal to 10 to the 5th, because it's open, plus 500 times 3 squared, so 9, minus, because that got subtracted, 500 times 11.5. So let's do the math real fast. So it's 500 times 9 equals that, minus 500 times 11.5, which would be, I don't think that's right, so I'm going to redo that. 500 times 11.5 equals that. So, no, wait, that was right. Oh well. 5,750 minus 500 times 9 equals 4,500. So now, it's going to be 4,500 minus 5,750. We're going to have a negative 1,250. And so now, 10 to the 5th equals that, minus 1,250. We have a smaller pressure right here, which is going to be P2 is equal to 0.98 or 0.99 times 10 to the 5th. So that's what P2 is. So let's put that up here. P2 is equal to 0.99 times 10 to the 5th. Erase this because we're going to need our space again. We're going to have to find the velocity here again. So we have 11.5 times 0.0013, which is equal to V3 times 0.0314. We're going to divide by this, move it to this side, divide. So 11.5 times 0.0013 equals that, divided by 0.0314. And what we get is V3 is equal to 0.48 meters per second. Now we're going to move that up here. 0.48 meters per second. There we go. Okay, and now all we have to do is find our pressure. So we're going to have pressure 3 plus rho 1/2, because we don't have height again. V3 squared is equal to pressure 2 times 1/2 rho B2 squared. So we have P3 is equal to 0.99 times 10 to the 5th plus 500 times 11.5 minus 500 times 0.48. Now let's do the math real fast. 500 times 11.5, which is going to be 5,750, minus 500 times 0.48, which is going to be 240, which we could do right here. So 5, that's going to be 510, plus 0.99 times 10 to the 5th. So 0.99 times 10 to the 5th, plus 5,510. So what we get is P3 is equal to 1.05 times 10 to the 5th. And that is our answer. Thank you for watching. I hope this helps you understand more about lift and Bernoulli's equation. And if I do future videos, thanks for watching.